All right, let's get right into it. Today, we're going to talk about a procedure that is, and I mean this, absolutely critical in any industrial setting. It's something designed for one single incredibly important purpose, saving lives. We're talking about lockout, tagout. And you know, this quote really says it all. This isn't just some recommendation from a safety manual. Lockout, tagout, or LOTO, is a lifeline. The entire system, the whole reason it exists, is to stand between a person doing their job and a potential tragedy.
The main goal here is pretty simple. Stop a machine from accidentally starting up while someone's working on it. Just picture it for a second. You're doing maintenance on a massive piece of equipment, you think it's off, and then suddenly it just roars to life. While lockout tagout is the system that's built to make absolutely sure that scenario never, ever happens.
Which brings us to the big question, right? If we have this fantastic safety system, why do we still hear about these horrible accidents? Well, the answer, almost every single time, comes down to one thing: the human element. The system itself is solid, but it only works if it's followed perfectly, every single time.
So let's actually break down what this solution is. What exactly are we talking about when we say lockout, tagout?
At its core, it's a physical barrier. It's literally about taking a padlock, a real physical lock, and putting it on the power source for a machine. This makes it physically impossible to turn that machine back on until the person who put the lock there comes back and removes it themselves. It's such a simple idea, but it's incredibly powerful.
Okay, now let's get into the nitty-gritty. How do you actually take a piece of equipment offline safely? You'll see this is a very deliberate step-by-step process, and for very good reason. Look at how careful this sequence is. You go from getting permission, to checking with everyone, to finally taking action. But look at that last step, step 6. Attempt to start the equipment. This is the magic key. You don't just hope you did it right, you actively try to prove that it won't turn on. It is the absolute final check that tells you for sure that the machine is isolated and safe. And here's where it gets really smart. The system uses different colored locks to show shared responsibility. So for example, the electrical team has a yellow lock, mechanical has blue, and so on. The rule is simple. The machine cannot be turned back on until every single team has come back and personally removed their own lock. It's a physical, visible symbol of teamwork and accountability. I know we just mentioned this, but I have to say it again because it is that important. You don't assume it's safe, you prove it's safe. This final check, physically trying to start the machine, is what confirms the lockout worked. It removes every last bit of doubt before anyone puts their hands on that equipment.
Okay, so the job's done. Now what? How do you bring the equipment back online? Well, this process is just as critical and just as strict as taking it offline in the first place. You can see it's almost a perfect mirror of shutting down, right? You get a brand new permit, but instead of trying to start it, you do a visual check to make sure everyone's clear. And this part is key. Each department has to come and take off their own lock. You can't ask a buddy to do it for you. It's your personal signature saying, my team is safe, our work is done.
And here is the golden rule, the final layer of safety. The electrical department, the ones who actually control the flow of power, they are always the last ones to remove their lock. That yellow lock stays put until every other team has signed off and removed theirs. Only then, and I mean only then, can the power finally be restored. So, let's put it all together side by side. This table really shows you the genius of the system's design. When you de-energize, you verify with a physical test. When you re-energize, you verify with a visual check. Putting the locks on is a group effort, but taking them off is an individual responsibility. And all the while, the electrical team is the ultimate gatekeeper. The whole thing is designed to be completely airtight. And all of this brings us to the most important and honestly the most vulnerable part of the entire system. Us, the people.
This right here is the heart of the matter. You know, sometimes the job is a quick 5-minute fix, but the whole lockout procedure takes 15 minutes. And that temptation to just skip it, it's real. But this is a powerful reminder that the amount of time it takes is totally irrelevant compared to the safety it provides.
And that's really the big takeaway. Consistency is everything. Think about it. A safety system that's only used 99% of the time is a system that's going to fail. It has to be done correctly by every person, every single time. No exceptions.
So I'll just leave you with this question to think about. We measure shortcuts in the minutes we think we're saving, but the real cost, the true cost, can be measured in lives. When it comes to safety, the long way is the only way. Thanks for tuning into this explainer.